All right, folks, so in this video, what I want to do is just do a little bit more on writing equations of lines. And what we're going to be doing is we're going to have given a slope and a point on the line. And we're also going to be taking a look at writing equations of lines that are parallel and perpendicular, given a line and a point on that line that is parallel or perpendicular. So the first thing we need to look at is we need to understand there's two different forms. So there's the point slope, which this is where we're going to start everything out of. Y minus y1 equals m times x minus x1. And then I've got the slope intercept, which is where I want to get to. And that's everyone's favorite, y equals mx plus b. So with these two, now all I need is just a slope and a point on the line. So if I'm given a slope of -3 and a point on the line of -2, 7, okay, all I need to do is just plug this into the point slope form. So here's my x1, y1. All right, so I plug this in. It's going to be y minus 7 equals -3. That's my slope times x minus. Now, this x1 is -2. So I'm going to use parentheses when I include that because I want to make sure that I remember all of the signs. It's very important that we have the signs in there and that the signs are correct. Otherwise, it throws off the whole problem. So the first thing I'm going to do is get rid of my double sign. So here I have x minus -2. So I'm going to go ahead and get rid of that. The minus and the negative go ahead and cancel and become a positive. So now I've got y minus 7 equals 3x, or -3 times the quantity of x plus 2. Next step is to distribute. Y minus 7 equals -3x minus 6, and -3 times 2. And then when I add a 7 to both sides, what winds up happening is I get my answer, which is going to be y equals -3x plus 1. Okay, so writing the equation of a line from when I have the slope and the point on the line is as simple as putting it in point slope and then solving for y, which will give us the slope intercept. Now, if I needed to find if something was parallel or perpendicular, it would just work similarly, but we would just have to find the slope and work within there. So we know that parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes. So I'm going to write here parallel, same slope. Okay, and I'll just write P-E-R-P for perpendicular, and we're going to say opposite reciprocal. So as I am doing the math and working through these problems, you'll be able to determine whether or not we're going to have to do parallel or perpendicular. So let's actually start out with an equation, y equals -3x plus 5. So this is going to be my given equation. I want to find what is the equation that is perpendicular to y equals -3x plus 5, passing through the point 9, 7. Okay, so if I'm going to go through the point 9, 7, what I do is I have to find out what is the slope of this line. Well, the slope of the original line is -3. So if I'm going to go perpendicular, the slope of the perpendicular line has to be the opposite, so it's going to be positive, and it has to be reciprocated. Well, it's like that. This is -3 over 1, so when I reciprocate that, it becomes 1/3. So now I know my slope of my perpendicular line, x1, y1. I do exactly what I did previously. Y minus 7 equals 1/3 times x minus 9. Okay, there were no negatives here, so I didn't have to worry about any of the signing. So this is going to be y minus 7 equals 1/3 x. We distribute minus, now we're taking 1/3 times 9, so that's going to give me 3. So again, I'm going to add 7 here. and I'm going to wind up with a final answer of y equals 1/3 x plus 4. Okay, so that's finding if it's perpendicular. Parallel is very similar, okay, except parallel, the slopes actually stay the same. So being able to work through these is extremely helpful. I find that most students have issues when we go to parallel and perpendicular and writing the equations of the lines that are parallel to or perpendicular to a given equation with a given point. Let's just wrap everything up by talking about a parallel line now. Okay, so again, I am going to change my equation. Let's make this y equals negative 4x minus 6. As I mentioned, we're going to do this one parallel. And then it's going to be through the point negative 3, positive 4. Okay, so we find the slope of the first line, or the given line rather, and the slope of the given line is going to be negative 4. So the slope of the parallel line, that's just the symbol for parallel, and the previous was the symbol for perpendicular, is going to be the same, negative 4. So I have my point of negative 3, 4. So again, y minus y1, which is 4, equals m, negative 4, times x minus x1, which is negative 3. And again, I use parentheses because I don't like to have any issues in terms of signs. So again, I look here. This one is going to change to addition. Y minus 4 equals negative 4 times x plus 3. And then we're going to distribute. So after I distribute, I have y minus 4 equals negative 4x minus 12. And again, it's minus 12 because this is a negative 4 distributing over addition. And then I simply just wrap everything up by adding by the 4, and I get y equals negative 4x minus 8 as my final answer. So again, this was just to kind of further reiterate how to write equations of lines given a point and given the slope. So you can see here we did that the first with just a point and a slope, plugged it into point slope, and wrote the equation of the line in slope-intercept form. Then we were able to work through another 2 examples, one on perpendicular lines where we had the opposite reciprocal for the slope, and then one on parallel lines where we had the same slope. So I hope you're able to pick something up from this video. Thanks.